Hello. Um, let's talk about Ira Remsen and an experiment that he did. He was a chemistry student. This is about mid 1800s, 1860 or so, 1870, and he was actually a physician. And he later went on to become the second president of Johns Hopkins University, and he was a very famous chemist in the latter half of the 19th century and the first quarter of the 20th century. And his renown was so that he won the American Chemical Society's Priestley Medal, which is the highest honor that they bestow. Now, Ira was studying one day while he was a student and came across this phrase in his textbook: nitric acid acts on copper. Nitric acid acts on copper. Well, he wondered what that meant. What does that verb phrase acts on mean? And so he knew a little bit about copper and metals, and you know some things about metals: that they're hard, that they're ductile, that you pull them out in wires, that they're malleable, that you can pound them out, flatten them out, that they conduct both heat and electricity. And he knew some things about acids: that they're corrosive, that if you taste them, some of them you can safely, that they're bitter. Where do you find acids? You find in your stomach. You got 1 molar hydrochloric acid there. Citric acid in fruits. Lead storage batteries in cars have sulfuric acid in them. Of course, they didn't have cars back in Ira's day. But he knew a little bit about acids. But he wondered what that phrase, nitric acid, acts on copper. So he was thinking about that, and he reached in his pocket and he pulled out a penny. And back in those days, they were made completely out of copper, of course. So he decided he would do an experiment. Now, this is his 1860-ish lab, and so there's no electricity, there's no running water, etc. And so he puts the penny down on the table and is going to conduct this experiment. Well, I'm going to be a little bit safer. I've got my safety glasses on, I got my lab jacket, and got my at least one glove on that I'm going to be using. I guess I'll be safe and put both gloves on now that I'm to this point. And so I'm actually going to put it in this beaker so that it'll be a little bit safer. And then he looked around the lab and he has some nitric acid. And so nitric acid is a clear, colorless liquid. So let's add a little nitric acid. And you saw the penny. It's got a copper patina on it, copper coating, copper oxide. So it's got a brownish color. And so we're going to add a little bit of nitric acid. And he goes, wow, look at what's happening. Can you see there's a brown gas being emitted? And the solution has turned green. And it's bubbling. And this brown gas is starting to fill the room. And nitric acid, and Ira goes, that's really neat. Nitric acid acts on copper. But he's getting all choked up about things. And so what Ira's going to do is he grabs the penny, runs to the window, and throws it out. Feels a lot better now in terms of the gas and the smoke. But within seconds, he realizes that he didn't have gloves on. He goes, his fingers are starting to burn. So nitric acid acts on fingers. And I'm about to asphyxiate here from the brown gas. So let me quench this reaction real quick. We'll come back and talk about that in just a moment. But back to my story. His fingers are starting to burn, so nitric acid acts on fingers. Well, this is 1865-ish or whatever, and no running water. His fingers are burning, so what are you going to do? He decides he will wipe them on his pants. Feels a lot better. But then a few minutes later, he looks down at his pants, and he's got holes in them. So now he's learned another lesson. Nitric acid acts on trousers. And so this wound up being a rather expensive experiment, costly experiment for Ira. It cost him a penny. Now, back in the 1800s, a penny was actually worth something. And he got some burnt fingers ever so slightly, and he lost a pair of pants, which really cost him a lot of money. But it showed him the wonders of chemistry, and you really came to understand what it means for nitric acid to act on copper. And we'll be looking at that experiment a little bit later. And but I wanted to show that to you, and that what it really shows you is that the way we discover new things in science is by doing experiments. The best thing to do is go and read and see what other people have done before you. If Ira could have had some better resources and had some more time, he might have been able to read about what it meant for nitric acid to act on copper. But he didn't. He went ahead and did an experiment, which is fine. But the way we discover new knowledge in science is by doing experiments and using the scientific method, and where we generate a hypothesis, do experiments, gather data, come up with a theory, and then repeatedly test that theory. If that theory is good, we hold on to it until something better comes along. If it's not so good, we revise it or gen up a new theory. So that's not a story of Ira Remsen. Thanks for watching.